All right, so we're moving on to session 3 for lesson 4. We're going to talk about what the standard algorithm is for multiplication. And I think what really helps is to actually go over what a standard algorithm means. Before that, though, if you're in class, we went over the answers to yesterday's classwork. And now we're here to what standard algorithm is. So what the heck does that mean? So standard algorithm, when a math teacher says that, it just means that there's some commonly used steps they're used to solve this particular type of math problem. So what we're going towards when we talk about standard algorithm is the accepted, quickest, best way to do the math according to mathematicians. So that's the goal that we're going for. Earlier this week, we were going over different ways to do it with area models and breaking down into partial products. But right now, we kind of want to go towards this and that to be our end game. Before that, let's do a warm up. And with adding up all these partial products, I did notice there's might need a little extra practice with regrouping. So for this question right here, it asks, in this situation, how's regrouping used in this addition problem? And right here is where we actually have to regroup because we know that 8 plus 7 is actually 15, but you can't fit 15 here in the tens place. So we have to add that 10 or add that 1 over here to the hundreds place. And then we add that up with 6 plus 7 plus 2 is 9. And that gives us that. But again, each place in the place value only has space for one digit. So if you have a 2-digit answer, when you add up your column, you got to push that extra number over there. And in this case, it was 110. So we brought that over to the hundreds column for that. So again, just a quick review and a quick warm up about that. So the notes will start on page 65. And again, if you're doing this video from home, you can pause and rewind if I'm going too fast for you. So it wants us to find the product of 1,429 and 42. I still want to try it this way, where we break up one of these factors, in this case 42, into two different parts. So on the left, do 1,429 times 40. And over here, let's do 1,429 times 2. And sometimes students will ask me why I don't put commas here, like between the 1 and the 4 for 1,429. I try to not use that so kids don't get confused about decimal points and the commas. So yes, you could put it there, but for me, I don't do that, just for that reason. All right, so let's do this. Left-hand side first. So our factor is 40. So we're going to multiply 40 times 9. That gives me 360. The next one is 40 times 20. And remember, you take your 4 and your 2, and that'll give you 8. And then you count up your zeros, which there's 2 of them. Get that. And now it's 40 times 400. Take your 4 and your 4 here. That gives you 16. And then put on your 3 zeros. And let's do 40. Oops, wrong color. Let's do 40 times 1,000. And that equals, let's do the 4 times 1. That gives me 4. And then add up these zeros. 1, 2, 3, 4 zeros. It gives us 40,000. That's a pretty huge number. For us, it's going to be 57,160. Over here on the right-hand side, let's do 2 times 9. Gives me 18. And then 2 times 20. Again, multiply these together. That gives you 4 plus a 0. Let's do 2 times 400. Do 2 times 4. That gives me 8. And then bring over those 2 zeros. So it gives me 800. And then 2 times 1,000. It's 2 times 1, which is 2. And 1, 2, 3. So we got that. And this all adds up to 2,858. So those are our two partial products, but we really have to add them all together. So over here on the right, I've got a little space here, I can do it. And we will do some regrouping. So I'm glad we did that with our warm up today. It's 2,858. All right, so we got 8. 6 plus 5 is 11. It's a 2-digit number, so we got to bring that 1 over to the hundreds place. 8, 9, 10. That's another 2-digit number. Take the 1 into the thousands. 7, 8, 9, 10. We did it once again. We'll take that 1 over in the 10,000s. So it gives us 60,018 is the final product for that. All right, let's clear that out. Again, if I go too fast, just rewind the video and it should show you everything there. All right, so on the next page, we've got, you can do partial products and you can stack them up all in one spot. That's one way of doing it. And just add those up to get your final answer. I don't really promote this way of doing it. I like doing it split up into 2 different sides so your work doesn't get all messy. A lot of kids would not want to, or a lot of adults would not want to add up this many numbers all in one spot. So let's avoid that for now. And let's look at how we did it on the board before. So now here's the standard algorithm way of doing it. So this is the way you've been taught before and the way that we'll be doing it from this point forward. So I just want to point out a few things here. So down here at step 1, you start with multiplying by your ones. The ones are here in red. So this 2 is in the ones place. So we get a partial product of 2,858. And if you go back and look at our first page of notes, that's exactly what we got. Here's where it gets interesting for step 2. And I kind of want to block this off because this is an interesting way to think about it. Now we're multiplying by the tens. I'm going to make a little line here to point out this blue 4 right here. That's highlighted because that's actually 40. And we did learn that when we did our first set of notes and multiplied everything by 40. And it's the reason we get this 0 right here. Like anytime you got your placeholder, the placeholder 0 comes from us multiplying by 40, or the tens in this case, multiplying. So if you ever wondered why we put a placeholder 0 right there when we start our next line, is because we're not multiplying by 4. This 4 right here is actually 40, and that 0 right here gets put onto the partial product. So again, we just have to remember the why of why the standard algorithm works the way it does. All right, let's jump into the notes on the next page. And again, I'll keep these pretty short. Where do you see multiplying by ones and by tens in the first modellet? That's the one over there directly on the left. The red, the numbers that are in red, those are our ones. And the numbers that are in blue, those are our tens. So it's simple as that. So the red are the ones, the blue are the tens. Look at the second modellet. How do partial products 1840, 800, and 2000 relate to the first step of the standard algorithm model? That's pretty easy. If we added all these up, so there's sum. So when you add up numbers, the answer is called a sum. Those are all the first partial products. So this next question, where we're adding up these numbers right here, their sum is the second partial product. That's where those numbers come from. And if we complete the multiplication of this, which we already did on that first page, we know 1,429 times 42 is 60,018. And I will put a comma there just because. 5, compare the partial products model and the standard algorithm model. They both start with multiplying the ones and tens. That's how they do that both. You can get the same answer either way. Let's cross off 6, and let's do these 3 problems over on the back and finish up for that one. All right, so for this one, number 7, says the base of a storage bin has an area of 504 square inches. Its height is 18 inches. Over here to the right, what this means is just like our volume question, volume equals base times height. So again, I like how sometimes these lessons kind of call back to when we did what we did in the previous lesson. So this is volume equals base times height. So our answer will be in cubic inches. So just remember that. We've got inches here, but they're going to be in cubic inches. Sometimes it's good to write a little reminder so your final answer is correct. But we set it up the same way. So we've got 504 times 18. And I'm going to do my ones in reds, and then I'll do my tens in blue. So 8 times 4 is 32. We can't fit 32 into one place value, so we carry the 3. 8 times 0 is 0. Bring down your 3. 8 times 5 is 40. Since we don't have any other numbers, we can just stretch that out like that. So first step, since we're dealing with the tens, put your placeholder. And I also want you guys to get in the habit of crossing off these numbers we carry over from the ones, because we don't want those to get confused or added on when we do our tens. All right, so we could multiply 10 times 4, 10 times 0, and 10 times 500, but with this right here, with this, because of the tens, we don't have to do that anymore because we already tack on the 0 to everything we get out of that second partial product. That's why we can do 1 times 4 is 4, 1 times 0 is 0, and 1 times 5 is 5. What it also like for us to do is put a plus sign down here next to your partial products, because sometimes kids get confused because they've got a multiplication symbol here and then you got an addition symbol here, but that helps you remember to do it like that. So add up our ones. 2 plus 0 is 2. Add up our tens. 4 plus 3 is 7, or 0, and 5 plus 4 is 9. It gives us 9,072 cubic inches. All right, let's go on to number 8. A school supply store has boxes of markers with 25 markers in each box. There are 1,075 boxes of markers in stock. So they want to know how many markers they have all together. So this is another multiplication. 1,075 times 25. I'll do my ones in red. 5 times 5 is 25. 5 times 7 is 35, plus the 2 is 37. 5 times 0 is 0, but we still need to bring down that 3. And 5 times 1 is 5. Now I'll cross these out before I begin. We need this for our partial product because we're multiplying by our tens place now. 2 times 5 is 10. 2 times 7 is 14, plus 1 is 15. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2. Don't forget your plus sign. Add up our ones, add up our tens, add up our hundreds, add up our thousands. and add up our 10,000s. We get 26,875 pens. It's a lot of pens. Oh, markers. Excuse me. There's a difference between a marker and a pen. There. And one more question. All right, what's the product of 257 and 34? Use the standard algorithm. Well, we've been doing that the whole time. So let's do it right now. All right. So we start with our ones. 4 times 7 is 28. Bring over the 2. 4 times 5 is 20. Add up the 2, that's 22. 4 times 2 is 8, plus 2 is 10. So that's my first partial product. Down here, to 0 the x, it's because we're actually multiplying by tens now. Cross off what you carried over from the ones. 3 times 7 is 21. 3 times 5 is 15, plus 2 is 17. 3 times 2 is 6, plus 1 is 7. Got 8, add up our ones, add up our tens, add up our hundreds, and add up our thousands. 8,738 is our final answer. And that's it. For your classwork for today, I've got a lesson posted on Kami. You're going to be multiplying 3 digits by 2 digits, providing you with a paper copy to show your work, and also graph paper if you're here to add up your partial product. Some of us were getting our numbers in the wrong place value, and we need to make sure we're doing that properly. And you can submit that through Kami when you're all done.